In this example, we're presented with some data which is already presented in the form of a graph, a table, and a linear relationship which models the graph. So, in other words, the regression has been done to work out the equation here. And what we have to do is we have to make some predictions from the graph and from the equation, and then talk about and discuss the reliability of what we've come up with. So we're going to use the graph to predict the weight of the bird if 14 grams of hormone was given to it. So the graph is showing the weights of chickens with different amounts of hormones. It's got a rather awkward axis here. Each square is equal to 3 units. So if you want to have 14, you kind of have to divide that up into 3. Go up to the graph and go along to your axis. And using the graph, I come up with, for question number A, about 2.3 kilograms. Give it 14 grams of hormone, and you'll get a 2.3 kilogram chicken when it grows to be an adult. Now we have to convert the result using an equation. So we're going to use the equation. The weight is equal to 0.068 times the amount of hormone plus 1.375. Now we're going to do this when the amount of hormone is 14. So W equals 0.068 times 14 plus 1.375. Now it's not very hard here to work this out. 0.68 times 14 equals plus 1.375. I've done it beforehand, and I get the weight equals 2.33 kilograms, rounded to 2 decimal places. So we've got very similar answers doing it both ways. Next bit, part C, was predict the amount of hormone that would be required to raise a bird which weighs 1.8 kilograms. This time they've given us the weight of the bird, so we can go up here to get to 1.8, go across until you hit the graph, and then go down until you hit the axis, and you'll find that we're just a bit over 6, not up to 7, I reckon, for if you want to get a 1.8 kilogram bird, you will give them about 6.5 grams of hormone. Now we need to confirm that result using our equation. So you write down the equation again. Only this time it's W, the weight of the adult bird, that equals 1.8. We have to work out what H is to make this equation hold true. In other words, we need to shuffle the equation round until we get H equals something. Now the way that I would go about that is, first of all, take 1.375 away from both sides of the equation. That means 0.425 equals 0.068H. Then if you were to divide both sides by 0.068, you would have H. So on the calculator, 0.425 divide by 0.068, and we'll get 6.25 grams of hormone. And we'll give you that 1.8 kilogram bird. Notice a slight difference here, but there's a little bit of inaccuracy when we're doing this on the graph, isn't it? The last, next question says, use the graph to predict the weight of the bird if it was given 22 grams of hormone. Now, if you look at the graph, you'll see that it doesn't go up to 22. So what we need to do is we need to extend our graph a bit further. It goes up to 21, and these are going up 3 at a time, aren't they? So that next square is actually going to be 24, and 22 will be about there, dividing that up into 3s. So we don't have to go up much further, but we have to make our graph a bit longer. This is called extrapolating your graph. And we need to go from here, we need to go up to the graph and along to our axes. Oh, it didn't go straight. And had I gone along straight, it looks like I get about 2.9, 2.85, let's say. So the weight of the adult bird is 2.85 kilograms. Confirm it by using our equation. So, oops, let me just move up a little bit now, will I? So, using our equation, we're going to say, we know that the equation looks like this. And if we put in the amount of hormone as 22 and work out what W is, and I have actually done this before, and it works out to be 2.87 kilograms. If you give 22 grams of hormone, you'll get out a bird which weighs 2.87 kilograms. That matches our graphical answer pretty well. Now we have to answer the last question. Now I'm going to just pause, and you can think about this as well, and then we'll compare our answers. Okay, this is what I've come up with. I've said that our first 4 answers were all reliable. I've said that because they were using interpolation. They were asking us for information which was taken from within the bounds of the original data table. And when we got our answers, you can actually see that the sorts of answers we got out would fit somewhere in the table. They are very similar to the sorts of results that were being produced from the original data. But the last couple that we did, when we did it from the graph by extending the axis, and when we did it even using the equation, those results must be unreliable because we were using extrapolation. We would be assuming that this relationship holds true for data which has not been tested yet. And we don't know that. We've got no idea what happens when you give 22 grams of hormone to the bird, because the biggest amount that was given was 18. And it might be, it might hold true. You might find it holds true, but it might be that if you end up giving too much hormone, it's counterproductive and it doesn't produce larger birds at all. It might produce smaller ones. It may even kill the birds. So you cannot assume that a relationship will hold true for values which haven't been tested.